guys, we want to talk about case 3 of frictional force. Now, we don't forget, in this case now, they ask you, how many forces are acting on a body placed on a rough inclined plane? These are questions that they ask sometimes, especially for advanced program and even a program like Cambridge, TOEFL exam, and even 100 level exam, JAM. Now, there are 3 forces. Number 1, frictional force. Number 2, frictional force comes as a result of what? The rough surface. Because the body is rough, it's based on a rough surface, that's why frictional force will come in. If the body is smooth, then it will be 0. Because a perfectly smooth surface, the coefficient of friction is 0, and that will make friction 0. Number 2 is reactional force. Reactional force came in as a result of contact. It's a force that what? That is holding 2 surfaces in contact, and they what? One will slide or moves over the other. And it's always perpendicular to the force. It's always perpendicular to the surfaces in contact. It's always at right angle to the surface in contact. Now, where does the weight come in? Seeing as much the body has a mass, it's a particle, weight will come in. How? Weight is the gravitational pull on a body. It's the gravitational pull of the earth on a body. So there is no particle that does not have a weight, or there is no body that does not have a weight. The only thing that does not have weight is what? Anything that moves like a ray, that has like light rays and all that. Those ones are different. Now, in this case now, so we are able to tell you that when the body is placed on a rough surface, there are 3 forces that act on it. Frictional force due to rough surface, reactional force due to contact, and weight due to gravity. So that is what? Mg. Now, there is a what? We want to resolve the weight into 2 orthogonal direction. That means into 2 perpendicular direction. Now, if you resolve this weight, now don't forget this angle here is equal to this angle here. How? Because this is 90 degrees. And 90 plus theta will give us what? The what? Remove from here will give us what? Here will now be what? 180 minus 90 plus theta. Then if we now work with this one, knowing that the 2 of them, this is perpendicular, that means 90 degrees. And you call this one, let's say you call this one alpha, for instance. Alpha plus what? 180 minus 90 plus theta should be equal to 90, because this is a right angle. That means we call this part alpha. Then this one has been resolved as what? Remove, because sum of angle, this is a triangle. Sum of angle in a triangle is what? 180. This is right angle triangle. So if you now look at it that way, then you now discover that if you add these 2 together and remove from 180, you get this one. That's how we get this. So if you want to now get this alpha, how do you do about it? Alpha becomes what? Alpha becomes what? 180 minus 90 is 90. Then minus theta equal to 90. So what do? Take all this one to the other side to make alpha the subject of one. At the end of the day, I want to have alpha equal to 90 minus, this one come there, you have minus 90. Theta, minus theta go there, become plus theta. At the end of the alpha equal to what? Theta. So that means that's why most times we call this place theta. So take note of that now. I've proved that for you. Why that place is always what? Theta. And don't forget that if you resolve the word, don't forget the body is placed on a plane. They say a body of mass m is at rest, or just about to move, or just move. Then placed on a plane, inclined at an angle theta to the horizontal. So that is to say, m is placed on a plane that is inclined at an angle theta to the horizontal. This is the angle. Now, what we are going to do now is what? Let me remove all this one. Then we'll go ahead with it. Now, let us resolve the weight, this weight along the plane. If you resolve the weight along the plane and perpendicular to the plane, Here we give you resolving this theta with respect. This is 90. If you resolve theta along with the weight, we are going to have here as ng sine theta. This is gravitational force along the plane. Then perpendicular to the plane now, we are going to have mg cos theta. Now those people count it as part of the force. No. Now some people will tell you, oh, how many forces acting on the body on the rough incline? They will say it's 5. 1, 2, 3, 4, 5. That is blunder, my dear. You cannot do that. It's a big blunder. You know why? Because if I remove this weight now, these two will disappear. We will not see them. So this and this are resolution due to the weight of the body mass m. Now let us now go ahead. Now for the body to be at rest, that means sigma fy is equal to 0, fy prime, and sigma fx prime equal to 0. That means the forces along the y component, I call it y prime, and the forces along the what? The x prime will be equal to 0. Now y prime is one perpendicular, the forces perpendicular to the plane. So let's say resolving perpendicular to the plane. Then we have what? We obtain. Now, how many forces acting perpendicular? We have reaction up, which is R, should be equal to what? The mg what? Cos theta. Let's call this one equation 1. Equation 1. Let me clean this part so that we have already analyzed, so that the place will not be looking too rough for us to see. Just put that now. Now we go. Now resolving what perpendicular to the plane, to the inclined plane, you have what? That, meaning that now we resolve what? Parallel to the plane, or along the plane. We have what? What we have now is that now the frictional force. Why is even friction going on? It is spiritual for you to place a body of mass m on an inclined plane, and the body is going up without a force applied to it. Just imagine me slide the body. As I slide the body now the body now begin to go up. The body placed on an inclined plane. I slide the particular plane and I place the body on it. The expectation is that the motion will be down. And don't forget, the definition of friction is that it would act in a direction to oppose relative motion of two bodies in contact, where one slide over the other. This one is sliding over the surface. So frictional force will oppose, while the tendency of motion, that means the reality of motion should be this, but although we are assuming that the body is at rest, that's why the direction of motion will be in that way. So now in this case, now if you want, we assume that it's at rest. So mg or fr resolving along the plane is equal to what? Mg sine theta. Take that one as equation 2. Now let us divide equation 2. Divide 2 over 1. What do we have? If you divide the 2 over 1, follow me up. We are going to have what? Fr over r, which is this divided by this. Then mg sine theta over mg cos theta. So this one we cancel this. What we are going to have is what? Fr over r equal to what? Tan theta. Now, if you look at it very well critically, now we have fr equal to what? Equal to tan theta times r. Now, if you check from the beginning of the definition of the course, when I did part 1 of this video, I told you that frictional force equal to what? Mu r. I mean, now look at the board. What is occupying the position of mu here is tan theta. The position of mu here is tan theta. That means that coefficient of friction is also equal to what? Mu. It's equal to tan theta. So tan theta, so coefficient of friction, of limiting friction, let me put that way. of a body of mass m placed on a plane inclined at theta to the horizontal in a case where the body is just about to move or at rest or stationary. We say that mu equal to what? Tan theta. Please take note of that. Mu equal to tan theta. So that is to say this formula very very important. Now I've also was able to tell you that reactional force equal to what? Mg cos theta for when the body is what? Just about to move on, placed on an inclined plane. I've also what? Told you that what? Frictional force equal to what? Mg cos theta, Mg sin theta. That means frictional force is what? Equal to gravitational force along the plane. Now if they ask what is the weight? The weight of the body, of body mass of the body m along the plane. The answer is what? W what? Sin theta. What about if they ask you the what? Parallel or perpendicular to the plane, perpendicular or right angle or at what? Let me just put something there. Or right angle to the what? To the plane is W what? Cos theta. So I will stop this class like this. I believe I'll be able to explain the condition when the body is placed what on what a plane inclined at an angle of theta and the body is assumed to just about to move or stationary or at rest or just move. Thank you.